Hello, dear students. Welcome to all of you in this first class of BSc second year. So, I hope ki all of you are fine. And today we are going to start the syllabus of paper number 10 in organic chemistry for your syllabus for this semester number 4. This paper carries 50 marks for this semester, and in this paper what we are going to learn during this semester. So today we are going to discuss one by one what is your syllabus of this paper, how we can discuss in this paper, what we will going to learning during the in your semester number 4. So this is the syllabus of your paper number 10 in organic chemistry. This paper is divided in 6 chapters. Chapter number 1, chemistry of elements of first transition series. Chapter number 2, coordination compound. Chapter number 3, chemistry of lanthanide elements. Chapter number 4, chemistry of actinides elements. Chapter number 5, acids and bases. Chapter number 6, non-aqueous solids. So these are the 6 different chapters we will going to discuss, we will going to learn in this fourth semester of your course in organic chemistry paper number 10. So one by one we will going to detail about the topic we will going to learn under this 6th chapter. In that chapter number 1, that is a chemistry of elements of the first transition series. So this chapter, under this heading of this chapter, we will going to discuss what is meant by the D block elements. First of all, we are going to discuss learn what is meant by the concept of the D block elements, general characteristic features of the D block elements, properties of the elements of the first transition series. Means the D block elements are divided into the 3 series. One is the first transition series, second transition series, and third transition series. So under this heading we are going to discuss, we will going to discuss only first transition series element of the D block element, in that first starting from the scandium and end to the zinc. After that, what are their ionic size, means the properties of the first transition series elements. During this series, what are the ionic size of the first transition series elements. Second thing is atomic size of the first transition series elements. Next one is the metallic properties, which are the metallic, which are the metals and which are the non-metals, what are their metallic characters, what are their metallic properties. And these properties we will going to discuss under the heading of this first chapter. Next thing is ionization potential. What is the concept of the ionization potential? What are the order of the ionization potential in the first transition series elements? Means from left hand side to right hand side, means from the scandium to the last one, that is the zinc. What are the trend of the ionization potential, and which factor is responsible to increase or decrease the ionization potential of the first transition series element in this D block element particularly. Next thing is a magnetic property. In under this heading of this particularly point, magnetic properties, we will going to discuss what is meant by the magnetic property, what is meant by paramagnetism, what is meant by the diamagnetism, what is meant by the concept of the ferromagnetism, which kind of the molecule they will get shows the paramagnetic properties, which kind of the elements complexes molecule they will get showed exhibited the particularly diamagnetism diamagnetic properties. On the basis of this property, we can particularly by calculating the magnetic moment of the compound, and we can exhibit it, we can explain the molecule, they will get explain magnetic property, it is a paramagnetic or it is a diamagnetic. And last one point of this chapter is the oxidation state. What are the oxidation state of the molecule, which is a stable oxidation state of the molecule, which is a common oxidation state of the first transition series element, and which elements किंवा particularly what are the minimum oxidation state and what are the maximum oxidation state of the all 10 elements are present in the first transition series in a D block element. Okay, so this is the first chapter. Chapter number 2, this is the most important chapter about particularly your incoming university examination. Because of that, this is chapter is having a maximum number of weightage for your university examination. In this chapter we will going to learn the Werner's coordination theory and its experimental verification. What is the concept of the Werner's theory of the coordination compound? Under this theory, what is meant by the primary valency, what is meant by the secondary valency, which metal atoms they will get, how we can indicate the primary valency, secondary valency, which molecule they will get exhibited the confirm their primary and secondary valency, how we can denote these valencies in a coordination compound, particularly in a inorganic complexes. Most important point of the coordination compound is the effective atomic number, that is EAN. EAN concept किंवा effective atomic number concept of the coordination compounds. On the basis of this EAN concept, the molecule will be the stable or unstable. We can explain easily by calculating the effective atomic number of the coordination compound of complex molecules. Then next concept is the chelates. What is meant by the chelation? What is meant by the chelates? In that chelates, during learn this point, we will going to discuss what is meant by the monodentate ligand, what is meant by the bidentate ligand, which kind of the ligands are mostly useful to formation of the chelates, what is the actual concept of the chelates, and why this chelation chelates they will get explain the increases the stability of the coordination compound. This thing is most important, and this thing will be the we will discuss in detail in the chapter number 2. Next important point about the coordination compound, that was the nomenclature of the coordination compound. Under this heading, we will go into how we can assign the name of coordination compound by using the different kinds of the rules, and how we can write the name of metal atom, how we can write the name of ligand molecules, how we can write their oxidation state in bracket. So this one by one we will going to learn under the heading of nomenclature of the coordination compound. Isomerism in coordination compound. What are the isomerism in coordination compound? How many type of the isomerisms exhibited in the coordination compounds? What is meant by the particularly concept, and how we can explain this coordination compound? What are their examples of the isomerism of the? This is the most important point about your incoming examination, regarding your examination. And the next important point is the valence bond theory of the transition metal complex. Okay, what are the valence bond theory? In shortly, we know that is the VBT. VBT is the valence bond theory of the transition metal complexes. Next chapter of the syllabus is the chapter number 3, chemistry of the lanthanide elements. So under this chapter we will going to learn what is meant by the DF block elements. So lanthanide series and actinide series, these are the these two series under the F block element in a periodic table. So we will going to learn the what is meant by F block elements, and how they will get differentiated, how we will get that classified into two series. One is actinide and another one is the lanthanide series. Under this heading, occurrences and isolations of the lanthanide, how we can occur or how we can isolate these lanthanide elements in various kind of the, particularly using the earth crust, the ores coming from the earth crust. After that, we will going to discuss the electronic configuration of the lanthanide series elements. What are their outermost electronic configuration of the lanthanide series element? Why this series of the element, particularly why the F block elements is known as intertransition series element. After that, oxidation state of the lanthanide series element. What are their oxidation state? What are their common oxidation state? what are minimum oxidation state and maximum oxidation state of the lanthanide series element. After that, their ionic radii. What are the trend of the ionic radii from left hand side to right hand side in the lanthanide series elements? Which factor is responsible to increase or decrease the ionic radii of the various kind of the ionic molecule of the lanthanide series element. And the last one is the most important point. Definitely this kind of the maximum number of the examination they will be asking on a write a note on lanthanide contraction and its consequences. So what is the concept of the lanthanide contraction? What are the causes of the lanthanide contraction and what are the consequences of the lanthanide contraction? These are the most interesting and important point in this chapter. Chapter number 4, actinide series element. Similarly, we will going to discuss the occurrences and isolations of the actinide series elements, position in the periodic table, where these elements are kept in a periodic table, what are their exact position in the periodic table, what are the electronic configuration of the actinide series, similarly what are their oxidation state, and finally chemistry of the separation of neptunium, plutonium, americium and uranium, how we can separate these elements from the uranium. So uranium, how we can prepare this neptunium, plutonium and americium from uranium ores किंवा uranium isotope by passing or by bombarding the alpha or beta particles on that particularly radioactive elements. Next thing is here chapter number 5. It is a very simple and basic chapter for your syllabus. Under this heading of the acids and bases, we will going to learn the different 5 concepts of the acids and bases. The first one is RNA's concept of the acid and bases. Second one is the Bronsted and Lowry concept of the acid and bases. Third one is the Lux and Fluid concept of the acid and bases. Fourth one, the solvent system concept of the acids and bases. And last one is the Lewis concept of the acid and bases. Means we will going to learn in detail all 5 important concept of the acids and bases. Means under this concept, what is the definition of acid, what is the definition of base, and what are their examples of the particular kind of the concept, and which acid is known as areneous acid, which acid is known as Bronsted and Lowry acid, which acid is known as a Lewis acid. In detail we will going to learn the acids and bases under the heading of chapter number 5, acids and bases, the last chapter of our syllabus, and that chapter is a physical property, non-aqueous solvents. What is mean by the aqueous solvent and what is mean by the non-aqueous solvents? Under this heading we will going to discuss here water, liquid ammonia and liquid sulfur dioxide. These non-aqueous solvents we will going to discuss here, the liquid ammonia and liquid sulfur dioxide, and what are their physical properties, types of the solvents and their general characteristic, reactions in non-aqueous solvent with their references to the liquid ammonia and liquid sulfur oxide. So we will going to discuss the 2 solvents in detail, the liquid ammonia and liquid sulfur dioxide, and during this study we will learn or discuss the what are different kinds of the chemical reactions will be occurring in the liquid ammonia and liquid sulfur dioxide. Okay, so dear students, I hope कि all of you are understand कि what we will going to learn in this semester under the heading of inorganic chemistry paper number 10. So thank you. If you like this video, please like and share with your friends. Thank you so much.